Okay, the lab that we did in class today had to deal with air pressure and how temperature is affected by air pressure. As we look at a bottle here, we see we have a liquid crystal thermometer. Inside we can see the liquid crystal thermometer is at about 78 degrees. The pressure is very, very high. We have a one-way valve on here that you can see at the very, very top. That is pressing air into the 2-liter bottle and not allowing any air to get out. As I unscrew the lid, we're going to see the temperature go down in the bottle, and you can see it was at 78, and you can see now that it's at 75. It's a little tough to see, and it is even shrinking down from 75, or cooling down from 75 even further down into the 71 area. So you can see as we decrease the pressure, temperature decreases, and that same thing would happen if we increase the pressure. We would see that the temperature would also increase. We have a worksheet that went along with that, and all the students got to do this at their groups with 2-liter bottles of soda and liquid crystal thermometers. They didn't have the one-way valves, but they got to compress the 2-liter bottles, and they got to see the temperature increase as they did that. And then with the second question there, why does that happen with the movement of the air molecules, and explaining the way the air molecules move. The kinetic energy, or the motion of the molecules, increases with the increase in pressure. When we start to get the air molecules bouncing around in there, and they start to bounce into each other and into other objects, they're going to start bouncing around more often, and they're going to start moving faster. And as they start to move faster, the temperature, or the amount of energy inside, is going to increase. How is this similar to one of the labs we did very early on in the conversations we had on weather when we were dealing with the syringes and air pressure? It's very, very similar. As we would compress the syringes and push the plungers down, it would decrease the amount of space that we would have for the air molecules, and the same thing happens when we compress these soda bottles. Same amount of air molecules, now in a smaller space, and when we decrease the amount of space, it increases the pressure. Increase in pressure leads to an increase in temperature. Okay. The temperature has to go up in the syringes when we look at this last question as well, because we are increasing the pressure inside the syringes, and with an increase in air pressure, we see an increase in temperature. One of the other things that we did also was we created a cloud in the bottle, and that's what we're going to look at next as I get that video. To create the cloud in the bottle, we have some of the materials here. We have some water that we're adding to this 2-liter bottle. We need a little bit of water vapor inside the bottle. We're going to shake up some of that water so we can get some water vapor in there. So we'll shake some up and make sure that it is covering the inside of the bottle. Then we're going to add a little smoke to the bottles. The smoke is going to create a little dirt or dust, a little condensation nuclei. The condensation nuclei is very, very important. That's what's the surface that the water droplets are going to condense on and stick back in when we cool them down to the dew point. So as we just seen from the last experiment that we did, when we increase the temperature, that's going to allow more water vapor to get into the air. And then when we decrease the pressure, it's going to decrease the temperature, cooling it back off to the dew point, and there's going to be a saturation or oversaturation of water vapor in the air, and that will then lead to that water vapor changing from a gas back to a liquid, or condensation taking place. And that water vapor will stick to the little imperfections and smoke in the bottle, and we will get a cloud to form in the 2-liter bottle of soda. As I unscrew the lid, it's going to decrease the pressure, and we can see that the cloud formed inside the bottle. If I increase the pressure again, it will warm the air back up. Those liquid water droplets will then go back into the atmosphere and become water vapor again as the temperature increases inside the bottle, and the cloud goes away. And then as I then again decrease the pressure inside, it will cool the temperature back down to the dew point, and we get a cloud forming in the bottle again. Next, we read an article in the book on observing clouds, and it started talking about how clouds form, the different types of clouds, what the different types of clouds mean, and it goes over where the clouds form, and again, what some of the different types of clouds are, and gives the names of the different types of clouds as well. It goes through a whole bunch of different ones, and it goes over high-level clouds, low-level clouds, storm clouds, and then it has some questions at the end. Okay, and with the questions at the end, okay, we have the answers to those. Okay, looking at weather observations and the weather chart, which we've done in the class. If we had cloud observations, what were the most common type of cloud observations? And we talk about the types of clouds that we see, and most of the time it's going to be some type of cumulus cloud and a type of stratus cloud. And the cumulus clouds are more of the puffy white clouds, and the stratus clouds are more of the layered clouds that are going to try to fill the air. Try to identify the relationship between the types of clouds and other weather observations. For example, air pressure decreases, what type of cloud would you expect to see? And again, the answers vary on these, and we kind of just picked more examples for the day that we were in class, and we can look out the window and kind of see what we can. But we have here, students might notice on high pressure days that they observe high level clouds, such as cirrus clouds, and on low pressure days they might observe low level clouds, such as stratus clouds. If stratus clouds fill the sky for several days, what does that tell you about the stability of the air, and what kind of weather might you expect? The conditions are fairly fair and stable. Stratus clouds, when stratus clouds are observed, some type of clouds produce light rain, others produce precipitation. So stratus clouds are going to mean that pretty much everything is staying the same. We're not going to get a heavy, violent storm when we get stratus clouds. Here in the third question we have about cumulus nimbus clouds, often form in the afternoon. What kind of weather and land conditions might contribute to the forming late in the day? And we're talking about solar heating, and this goes back to even what we talked about with relative humidity. As the air temperature starts to cool down, we start to get then these thunder showers. So the ground below cumulonimbus clouds heats up all day long. Convection may happen, and the heat from the ground is transferred by conduction to the ground just above the air. As the air warms, it's going to rise, then it's going to cool and sink. There would need to be enough water vapor in the air and cloud nuclei available for the cloud to form in the rising air. Okay. In the reading there was a quote there by Godfrey. What do you think it means? And that particular quote was talking about clouds look like they are made of something you can touch and hold on to, like cotton balls or fluff, but you wouldn't be able to hold on to a cloud if you really try to, because they are made of water vapor droplets, and they would just make your hand damp. Again, they're just condensation. And then the last question is there about illustrating a poem on clouds. So that was what we talked about when we looked at clouds. We also looked at what cloud droplets would be like, and typical cloud droplets are very, very small. So we're looking at a millimeter for the size of the droplets, and in this case the cloud droplets would be like 2/1000ths of a millimeter. So that's what's going to make up the clouds. As the raindrops get larger, they're going to get about 2 millimeters in size. So when they get to about 2 millimeters in size, they can no longer stay supported up in the clouds, and then they start to fall down as precipitation, whether it's rain, snow, sleet, or hail. If you have any questions on clouds forming or precipitation, feel free to stop by in class and ask.